it's Cliff here. It's been 6 years now since I've been manufacturing the Hallmark impact tolerant touch probe. So the 6-year anniversary, and I want to go into showcasing the manufacture of the Stylus assembly and also discussing the Hallmark product range. And I'm going to break from tradition a little bit in this video. If you stay on to the end, I'll discuss a little bit about the Hallmark business and maybe of interest to some of you in the US of A. So I want to talk about briefly the history. You remember back in 2015 I bought one of these probes, and I realized that for a CNC machinist a probe is a game changer because it saves so much time setting up your job, setting up your work offsets. And so I thought, it's just a brilliant thing, but there was problems with it. It wasn't particularly accurate or reliable, and obviously it wasn't impact tolerant. So I spent a lot of time in 2015 developing a probe that had those features: accuracy, impact tolerance, and what I hoped would be long-term reliability. Well, it's been 6 years now and it's shown to be incredibly reliable. I was able to test back in 2015 that I had good accuracy and good impact tolerance. It's not possible to test what the long-term reliability is going to be like. You can do different tests, electrical tests and measurements to sort of give you a pretty good idea, but there's no real proof like actually time establishing that something has good long-term reliability. And if you look in the Hallmark Design website under the testimonials page, you'll see a lot of very happy customers' comments, and these were given of their own volition. These were not prompted, and so I quoted them in that page. Over the years I've been enjoying making improvements to the product. Although it's the same internally, I've now got a Pro version. You're probably aware that it is pluggable and unpluggable. So you've got different cable options, and it's just easier to handle without the cable permanently attached. Also, the body on the Pro is fully anodized, so hard anodized in cap and body, so it has really good scuff resistance. Also, in addition to the TTS 3/4 inch shank, there's now a 12mm shank that allows you to fit it straight into an ER collet spindle, or to fit an adapter so that you can have, for example, a BT30 taper. In addition to those changes to the ITTP, I've been developing a range of lathe tool setters. And have a look at, I'll put a link in the description below to some of the introductory videos to these lathe tool setters. So now I'll talk about the manufacture of the Stylus assembly, particularly the tips and the stems. Here I'm making another run of the ITTP Stylus assemblies, and the stem is an important part of that. I'm using a very high grade, expensive, hardened and tempered and nitrided tool steel. It's absolutely bulletproof, and in order to cut them to length I need to wet grind them. So I'm using the cylindrical grinder with a cut-off wheel and coolant and a swinging V-block. Probably know that the Hallmark ITTP works on a different principle than other touch probes. Instead of having a fragile, self-sacrificing stylus, it has an extremely strong stylus assembly which is stiff and therefore accurate, and it deflects away on impact so that the whole stylus assembly is able to retract away from a crash. But that requires that each component in the stylus assembly is extremely strong. So we have this high grade nitrided tool steel, and spigoted into the stylus tips we have high quality bearing balls with deep holes spark eroded inside them, and the stylus stems are spigoted deep inside those bearing balls, so the whole assembly can stand a really violent crash. If you're interested to learn more about the Hallmark ITTP, there's a whole series of videos on the design and manufacture of the different components. Okay, so just looking at navigating the Thread Express YouTube channel, if you just go to playlists here, click on that, it'll bring up all the different playlists of different subjects, and if you come down to the bottom, you'll see there's the Touch Probe 2015 R&D. That goes into the history of developing this product. And so there's 9 videos there on that subject, and the other playlist is the Hallmark ITTP down here. If we click on that, there is a total of 29 videos on that Hallmark impact tolerant touch probe, going into different features and design points and manufacturing of components and so on. So that's just how you can find your way around and get information on this product. Well, let's go through the procedure of making these stylus assemblies for the Hallmark probes. So start off with the bearing balls and spark erode the holes deep inside them that allow the stems to be spigoted. I cut the stems out of that tool steel rod, which is hardened and tempered and nitrided, extremely tough tool steel. I then grind the little spigots on the end to give a deep mechanical connection between the stems and the ball tips. I'm at that stage at the moment. After they've all been ground to fit into the balls, I then remove the balls and grind the tapered portion to give you the clearance for probing. Then they're finally assembled into the completed stems. Then I pick up the hub and arm assemblies that I've already made and press in the stems. So that gives you the completed stylus assembly. That's quite a lot of work, but this is a key component of the impact tolerant touch probe. They must be absolutely bulletproof, really well engineered in order to allow the probe to be impact tolerant, to have a lot of retraction. There would be no point to it if this was a fragile assembly that would become damaged or broken. It needs to be highly engineered to allow it to withstand situations when the probe is impacted. So we're just burning down these stylus spigot holes, almost 3 millimeters deep, to provide a really secure mechanical connection between the stylus and the tip. So the balls are all conveniently at a 4 millimeter pitch, which makes it easy to set the position of the electrode with the DRO, and they can all be clamped together because there's a strip of aluminium down the side. Motivated me to develop the impact tolerant touch probe was that I had a probe that was not impact tolerant, highly accurate, or had long-term reliability, and I trialed different material choices for literally months until I got the combination that gave me those three features. Here are some of the hub assemblies with the hardened contact arms installed. I won't go into manufacturing those in this video because the video would just become too long-winded. Here I'm doing the final grinding stage. You might have noticed I haven't disclosed all of the key technical details, for example the finer points of the material choices and so on, because I want to keep some of the IP offline just in case there's a manufacturer somewhere that wants to copy the product. So I need to make that as difficult as possible. Obviously they can dismantle a probe and reverse engineer it, but it's difficult for them to know the exact material choices in some of the key components. Okay, well thanks for watching that video right through to the end. I just want to talk briefly now about the future of Hallmark Design Limited. Over the years I've come to realize that the main market for this product range is the US of A. And there's some real disadvantages in manufacturing a product like this in New Zealand, logistical and marketing disadvantages. And I need to be thinking about the future as well. So I'm thinking the ideal place for this to be manufactured long term would be in the US. So if you know somebody that might be interested, please let them know. They can contact me by email through the Hallmark website or through the Thread Express, this YouTube channel. By clicking on About, you'll see my email address there. It'd be really good to hear from them. Alright guys, well thanks for watching and catch you next time. Cheers.